Hello hello guys, so today we will discuss about one project which is NASA's near earth object. Okay, so this is an machine learning categorical project. So here we have to find out that the asteroid or the object which are in our outer space, they are hazardous or not. Okay, even here it's written that even though we might think that a distance of 70,000 kilometers can be not potentially harm us, but at an astronomical scale it is very small distance and can disturb many natural phenomena. So now we have to find um, and we have to classify those objects. Okay, so let's uh, move to the Jupyter notebook, or here I am just using Visual Studio. Okay, same thing. So here I'm importing some libraries like NumPy, Pandas, Matplotlib, Seaborns, etc. And here I have imported the data. Okay, then here I am using df.info for finding the data type, to find their null values or not. And here I'm viewing the histogram so that we can observe the distribution of um, various categories. Okay, and after that I'm just finding the dependent variable or the y variable, or we can say that the means main variable or labels, that they are hazardous or not. Okay, so they are separated into two distributions like true or false. See, uh, uh, in our outer space there are many asteroids or objects, so maximum of them are not hazardous. Okay, a small amount of objects are only hazardous, so they are not distributed in uniformly. Okay, so this is an important criteria also. After some time we will discuss those things, what model will be better for it. Okay, so here I'm also mentioning that we are not taking accuracy. So in classification model, we can accumulate our model by accuracy, precision, recall, and confusion matrix. So we will discuss that after. Okay, then I am using the df.describe. So this is a 5-number summary game. So here I'm getting maximum, minimum, standard deviation, mean, then 25 percentile, 50 percentile, 75 percentile. Here we can also find the IQR. You have heard about it in statistics. So IQR is the interquartile range. Okay, so when you study those things, then you will find that IQR is a very important measure to find out the outliers. Okay, so after that we are just dropping out the unwanted things, categories like id is not important. Then secondary object, it is the same all over the rows, so we are just dropping it. Orbiting body, we already know that the orbiting body will be art. Okay, so I am also finding the correlation between them. So see, established diameter, minimum and maximum are very correlated. Okay, so I'm also doing the feature engineering. In feature engineering I am using what, just check it, established diameter maximum minus established diameter minimum. This is the diameter of the near earth object. Okay, see, I'm also mentioning that I have checked the parameter as orbital deviation can increase the chance of the NEO, means near earth object, to be more hazardous, because if the orbit changes and reaches very near to earth, then new object will be pulled by earth's gravitation. Yeah, this is one of the main criteria also. So this feature engineering will be very impactful. Okay, so now I'm also using the df.head. Okay, then see, I'm splitting these things. This is an important thing. Okay, so this is also a feature engineering. See, the name here, it's written that 2000 here, 162635 2000 SS164. This is the name, but here it's mentioned that this is the year when the asteroid was first observed or discovered. Okay, so I am extracting out the years of every asteroid. So when I go to get those, then we can find it in which year we are getting more asteroids or less asteroid, like that. So after that I'm doing EDA. You have heard about the EDA is the exploratory data analysis. Okay, here we are just visualizing things, we are manipulating things. Okay, so first we are using box plot for the continuous variables. See, we have two outliers here. We can observe by the visualizations only. Okay, here also outliers are there, here also outliers are there. So uh, to rectify the outliers, we are first doing describe, then we are broadening the percentiles. Like previously we have 25 percentile, 50 percentile, and 75 percentile. Now we are just broadening up into 90 percentile, 95 percentile, and 99 percentile. See, when we are broadening up, then we get a better visualizations that it has some outliers, yes or no. So 95, 12, like that. See, 1 to 84. Okay, 0, 1, 46, like that. So to recover the outliers, or to um, release the outlier, or we can say delete the outliers, we are using this formula. Okay, quantile. I am getting the outlier. Okay, outliers which will be more than this value, then those will be considered as outliers. So that's what I am writing here. Okay, so after that I am just using shape to get the new shape, or the number of rows and columns. So right now I have this much of row and this much of columns. So from this only I will do the prior things. Okay, see, we have 909 outliers from this starting data shape and df dot shape 0. So I'm getting the outlier. So I will show you one thing more. So previously at the first step only I am just using df dot copy starting data. So for that thing was done because of this, to find the number of what number of difference. Okay, shape difference. So how much outliers are there. Okay, after that when we remove the outliers, then the visualizations will be like that, and we don't have that much of considered outliers. Okay, after that I am using pair plot. This pair plot will give you the full detail visualizations of every every your columns. Okay, so here I have already told you like that the established diameter maximum and established diameter minimum will be very correlated. So that's why it's linearly regression and straight line. That's why. Okay, then I am here. You are getting the skewed distribution also. After that, I am correlating with the years and the hazardous object detections. Okay, after that I am using the model conversion. Okay, see, I have converted the hazardous things from true to false to 0 to 1, because machine learning the scikit-learn won't understand any categorical values. Okay, so you have to provide every numerical values. Okay, after that I have done these things, you have already know maybe. After that I am using standard scalar things. So scaling, you have heard about scaling, na? So scaling is done to uh, means convert every data type into some similar measures. Okay, so to a limit. Okay, so if one column is like 1 to 1000 variation, and one column has 0 to 1 variation, then if we correlate it with the previous column to the next column, then it will be very difficult for us, and it will not give us the exact output. For that we are using scaling. Okay, so there are two types of scaling, one is standard scalar and one is min max scalar. Okay, okay, then I am using SMOT. Smooth is for to for those models where the output or the labels are not uniformly distributed. As I have mentioned previously, that these objects are means hazardous objects are not uniformly distributed, because we have a very large number of uh, unhazardous objects and very low number of hazardous objects. Okay, that's why I'm using smooth. After that, I have done those things using smooth fit resample. So these are done because to rectify those problems. Okay, after that I'm using standard scalar. Okay, so standard scalar is done. Then then I'm using extra tree classifier. Extra tree classifier is used to find the feature importance, means which feature will be more important and which feature will be less important. So establish diameter minimum is very much important, you can observe from here. Okay, so like that. After that I'm using stratified k fold. Stratified k fold is used because this is again this is an ununiform distribution. So I have using the splits into 10, so it will be split into 10 different folds. Okay, after that I'm using random forest classifier. Okay, so random forest classifier, you already know that, or maybe you don't know that random forest classifier is following a bagging method. Okay, so I will describe it like that in paint. Okay, so yeah, wait. So here you can see that this is the full train set. Okay, train set. Then I have initialize the datas into different bags. Okay, so for every bags I am taking one sample. So sample 1, sample 2, sample 3, sample 4, sample 5, and for every sample all bags we will consider as a train set. Okay, and after that we are implementing decision tree classifier. Okay, to every bigs. After that, when we are using those things, after that we will it can predict something, like it is predicting 1. Okay, 2 is predicting like 0, 3 is predicting like 1, 4 is predicting like 1, 5 is predicting like 0. So which output is maximum, you can see that 1 is maximum because it has 3, it is giving 3 times. Okay, so we are the output will be considered as 1, so the object is hazardous. Okay, so like that. After that we can see that when we use randomized search CV and those things, and we're using criteria as gene index, then we get the output as 94. So 94 is a very good score. After that when you use classification report, then we will get the precision recall, F1 score and support. So check 0.99 is the precision, 401, 495, like that. All scores are very good. So after that I'm just plotting it into a heat map, then it's showing like that. After that when I plot these things into a ROC curve, then you can check that the AUC is 0.99, means it is very accurate, because how much more AUC you gain, that much more better the model is. Okay, so this is our output. So thank you, and next video, it will be a short video there. I will implement these things and I will make one API, okay, app, by using Flask. Okay, so you can observe that this will be a very impactful and very beautiful project. You can convert outer space object as hazardous or not, and from previous data also you can detect that that object will collide with earth or not, or will impact earth, or it will do any harmful means criterion to earth or not. Okay, so yeah, for today. This is this project will be our priority, and for next time, for next video, I'm just implementing the everything to the API. Okay, and that API will provide you a better means visualizations, and it will be very beautiful. Okay, so stay tuned. Okay, please like the channel, subscribe the channel, and click the bell icon to know more about data science. And I'm also making some videos in my local language. Okay, so in Assamese, in Hindi, you will get the same things. Okay, and different things also. And I'm also teaching maths and calculus, as well as your statistics, and as well as Power BI also. Okay, so okay, stay tuned. Okay, now for now, okay, uh bye.